when you're looking at a question like this, what's the indicator that this is a quotient rule overall? How would you know to start with the quotient rule? Okay, so it's one function over another function, perfect. So we see a function of x divided by another function of x. Yep.
They're all to the same power.
Yes, and they're not all raised to the same power. Okay, it's not a fraction raised to a power. Perfect. All right, so then you're going to make your chart next. So you put your first function as 2x plus 3 cubed, and you'd write your second as 4x minus 7 to the 1/2. Okay, that's how the quotient rule works. The first function is on whatever's on the top, the second function is whatever's on the bottom. Okay? And then you want to derive each one. So if we derive this one, it's going to be 3 times 2x plus 3 squared, and then times 2. How did I get that times 2 again? Yeah, derivative of what's inside. Okay? That's a chain rule. Again, chain rule is going to have to be here, so 1/2 times 4x minus 7 to the negative 1/2, and then the inner derivative is 4. Okay, derivative of the inside is 4. I can multiply those together and get 2 times 4x minus 7 to the negative 1/2. And here I can multiply these two and get 6 times 2x plus 3 squared. And then I know it's going to go like that. Any questions with anything in the chart? How we got to that? Okay, so now you would write your first g prime of x. So derivative of the first times the second, look for any monomials in those two. So I'm going to have the 6 first. And then it's minus the first times the derivative of the second. So minus, and then I'm going to put my monomial 2 first. So order definitely matters in the quotient rule. All over the second squared. So that's the derivative right there. That's the calculus part. Everything else we do after this is algebra. So you want to put it into simplified factored form. So you're going to look at these two chunks that are in the...
Just so I forgot we talked about. I'm going to go up with you guys to the breakfast, and Ms. Northwood's going to stay back for those people who are not on the breakfast. It'll be, I think there's about 3 or 4 of my class that'll come down for mine.
Okay.
All right?
Yep.
Don't run away from me. And looks like I'm going to stay with you. All right.
Thanks.
God. Why did you put a square root in there, Mr. Oh, that's not nice.
There's always one for the test.
All right.
Okay, so if you look at your 2 big green chunks, see if you can write down what you think the greatest common factor is. See if you remember from yesterday. Anyone think they know the greatest common factor? Elijah?
2 4x minus 7 and the negative 1
Yep.
times 2x plus 3.
Perfect. Okay, so that's the greatest common factor. Now we want to divide each green chunk by the greatest common factor. Okay, so monomial, so 6 divided by 2 is 3. 2x plus 3 squared divided by itself is 1. Right? 4x minus 7 to the 1/2 divided by 4x minus 7 to the negative 1/2. Just 4x minus 7. Okay, so now I've divided the first green chunk by the greatest common factor. Now I'm going to divide the second green chunk by the greatest common factor. So negative 2 divided by 2 is just negative 1. And 4x minus 7 to the negative 1/2 divide out. 2x plus 3 cubed divided by 2x plus 3 squared is just 2x plus 3. Make sure you have those brackets. And then don't forget all over. So if I have a power to a power, what do you do with the exponents? Multiply them. So it's just 4x minus 7 to the 1. And then recognize the clouds. Whenever there's one like this, there's going to be clouds, like a function over a different function where it's quotient rule first. Okay, so all we've got left to do, we've got to divide our clouds, we've got to distribute and collect, okay? And then see if there's a common factor at the end. So we've got 4x minus 7 to the, so I'm doing negative 1/2 minus 1. Negative 3 over 2, good. So negative 1/2, so I'm dividing these powers at the same base. I'll write it over here again for a refresher. So that's going to be 4x minus 7 to the negative 1/2 minus 1, but I would write it as minus 2 over 2, which is 4x minus 7 to the negative 3 over 2. Okay, so that takes care of the clouds. Then I've got my 2x plus 3 squared. And then I've got, so if I distribute here, 12x minus 21 minus 2x minus 3. And I took care of the denominator because I divided these. Now that's going to move down to the denominator and become the square root of 4x minus 7 cubed. And in here we've got like terms, so 12x minus 2x is 10x. Negative 21 minus 3 is negative 24. And then you always check in the term where you common factored out of it if it can be factored. And 10x minus 24 can factor. Yes, what goes in, Colby? Yeah. So it's going to be 1 or 2 extra steps here, but it'll be completely factored. So I can change 10x minus 24 to 2. If I common factor 2 out of 10x minus 24, I get 5x minus 12. Now this is four things all multiplying together. So if I've got four things all multiplying together, it doesn't matter the order I multiply them in. So if there's 2 monomials there, I'm for sure going to multiply them together. So 2 times 2 is 4. It's going to be out. Okay? So I've got g prime x finally is going to be 4 times 2x plus 3 squared times 5x minus 12 all over the square root of 4x minus 7 cubed. So find the slope of the tangent to that curve at that point. Slope of the tangent to the curve at that point. So if you're analyzing this function here, what's going through your mind? Yep. Okay, so I could do that. I could totally do what Patrick said. Or I can do this. If I do it this way, I'm going to do quotient rule first, right? If I do it this way, I'm going to do chain rule first. You see the difference? Okay, so normally I just prefer to do the chain rule first if it's an option. I just find it, there's not a common factor and all that stuff. But your choice. If you feel comfortable with one method over another, then do the one that you like best. Okay? So if I did this one, I would probably do it this way. But if somebody wants to do it the other way, we can compare. Then do that. That's always fun. So if I did it, I would do it like this. And then my y prime would be chain rule first, so a half times this to the negative half. And then times the derivative of what's inside, and that's where I would go and make my chart. So to get the inner derivative, when I'm using the chain rule, my first is x, and my second is 8 plus x squared. The derivative of the first is 1. Derivative of the second is 2x. Why again is the derivative of x 1? I've been seeing that mistake on assignments. The derivative of x is x. How come it's 1? If you write it as a power function, 1x to the power of 0, anything to the power of 0 is 1. It's 1. Okay, so make sure you know that. That was yesterday when we did that question where t was, and everyone had the derivative of t was t, or not everyone, but a lot of groups did, so make sure you know that. All right, so now we're going to do the quotient rule. So derivative of the first times the second minus the first times the derivative of the second. So those are both monomials. You can multiply them together, but don't forget the minus. All over the second squared. So there's your raw derivative. We don't have to make it that pretty because we're subbing in 1, but we do want to make it easy to sub 1 in, so we don't have like an exponent of negative 1/2 or anything to deal with. So who remembers the rule of when you have a fraction to a negative exponent, what you can do? You can flip the fraction. Awesome, Patrick. And then the exponent becomes positive, right? And then up here we can clean it up a bit. So we have 8 minus x squared over 8 plus x squared squared. And then the last thing I would do before I sub in 1 would be to write this as square roots. So this is, I don't need that bracket. You can write this as the square root of 8 plus x squared over x times 8 minus x squared over 8 plus x squared squared. So now I'm finding y prime at 1. So that means I sub 1 into where every x is. So 8 plus 1 squared would be 9 over 1. That's nice. here I would have 8 minus 1 squared, so 7 over 9 squared. Yeah. Y prime at 1 would be a half times 3 times 7 over 81, which is really like 3 fractions multiplying together. Multiply the top together and the bottom together. So m tangent is going to be 21 over 162. And I know that reduces because I know 3 goes into 81. So it's going to give me m tangent is 7 over 81. No, 7 over 54. Thank you. Now, did it ask for the equation of the tangent line or just the slope of the tangent? So then you just leave your therefore, and you're done. Therefore, the slope of the tangent is 7 over 54. Did anyone do it the other way? No. You get the same answer when you sub in. Okay.